All right, today we are still working on solving systems by substitution. Today the problems will require a little bit more work on our part. So we will have to solve an equation for a variable, where yesterday we were already given equations that had a variable alone. It's the only real difference. So for our warm-ups, we already have a variable alone. Which variable is alone? Y. Y is actually alone in both of them. We just need it alone in one. So we can take this expression that's equal to y and plug it in for y in the other equation. So when I do that, instead of writing a y, I write 2x plus 1, and that's equal to the negative 3x plus 6. So I replaced the y with an equivalent or equal expression. Why did I not need parentheses around it this time?
Because they're both by themselves.
Good, they're both all alone, so there's nothing to multiply. Remember when there's something like a 2 out in front of the y, we would have to put a 2 and then parentheses around it. But they didn't do that this time, so we don't have to. Now that we've got our equation, we need all of our x's to be on the same side. How can I force that to happen? A couple different ways. Good, we could add the 3x. That's one option. If we do it to one side, we better do it to the other. After we add 3x on both sides, 2x plus 3x is 5x. Plus 1. What do we still have on the other side? A positive 6. The next thing we need to do, subtract the 1. 5x equals 5. Last step, divide by 5. Running out of space. Good, x would equal 1. Are we done? No, we found x, but we still need to find y. So we take that number that we got for x, and we bring it back up and plug it in for x. Especially on this problem, you could plug it in for either x. It doesn't really matter, but we'll go ahead and do it into the top equation. 2 times 1? 2. 2 plus 1? How do we write our answers to these? As an ordered pair, good. 1, 3. Remember, it always goes x, y, no matter which one you found first. Questions on the warm-up? Concerns? Need more time? Ready to move on? All right, these notes for our steps are technically the same as we did yesterday. So our first option is to solve one equation for x. The difference today is that hasn't been done yet for us. Yesterday we already had one that had x alone. Today we don't.
So we have to solve both of them?
Not both of them. We need to get x alone in one of them. Okay, so that'll be our first step. The next thing we'll do is then substitute into the other equation to solve for y. Then substitute y back into the original equation, solved for x, to solve for x. Okay, so those steps are technically the same as yesterday. We just actually have to do the first step. So we need to solve one of these two equations for x. So we could either do the top one or we could do the bottom one. I would agree that the bottom one is going to be easier in this case because all of these coefficients are divisible by 2. You could solve the top one for x, but you're going to end up with fractions that don't reduce or don't eliminate. So I agree that we are going to solve the second one for x. So So if you want to make a little note by it, put solve for x. That's like our first step. Okay, we decided that is what needs to happen. How are we going to make it happen? How are we going to get x alone?
Subtract 2y.
Good. Subtract 2y from both sides of the equation.
2y equals, wait, no, but minus 2y.
Okay, in this case, you could put it in either order. If you want to keep doing it the way we've been doing it, where you put the variable first, a negative 2y plus 6, that's fine. Technically on these ones, because we're not graphing it, you could just put 6 minus 2y. It means the same thing. What I cannot do is combine the 6 with the minus 2. Why not? Very good. The 6 doesn't have a y, so those are not like terms. We can't combine them. Is x alone yet?
No, it's not divided by 2.
Divide what by 2?
The negative 2y and the 6.
Good. Every piece gets divided by 2. Every single term in that equation. So we are left with x equals
Negative y.
negative 1y, or just negative y, plus
3.
3. Questions about getting x alone? Are we sure? Okay. So that's the only new part for today. The rest of what we're doing is just like we did yesterday. So if you want to, you could either kind of like separate it and say, well, I know I need to use this equation that I just made, solved for x. What's the other equation that I'm still using? So I need two equations.
3x.
Yeah, we need that one. We're using this one because x is alone, so we definitely want to use it. What's the second equation I'm still going to have to use?
3x equals y plus 1.
Very good. The 3x equals y plus 1. That's still part of it, and I haven't done anything with it. We got to use it.
Divided by 3.
We don't need to solve both of them for x. We only need to solve one of them for x. Technically, you could do that, but you don't need to. Okay, so now it's like where we started when we were doing these yesterday. We have x alone, so we're going to take this,
Parentheses.
yep, and plug it in.
Plus 3.
So we're going to take this expression that x was equal to and plug it in. And Jasha said parentheses, which is good, because we have to remember that we're multiplying or distributing the 3. Okay, when we distribute, we get negative 3y plus 9.
Equals y plus 1.
We need all our variables together.
Can't we put the y over?
Sure. You can go either way. You can move the y to the left, or you can move the negative 3y to the right.
The y, just the y.
Okay, how are we going to move it?
Subtract y.
Negative 3y minus y.
2y.
Careful.
Negative 4y.
Negative 4y.
Plus 9 equals 1. Subtract 9.
Subtract 9 on both sides. Negative 4y equals
Negative 8.
negative 8. Last thing I need to do,
Divided by negative 4.
divide by negative 4.
Y equals 2.
Y equals 2. Okay, let's pause there. We've already done a lot of work and we're not done yet. Do we have questions so far? Especially anybody that wasn't here yesterday, so this is like brand new for you. Nothing? Okay, we have y. We still need to figure out x. So we're going to take this number for y And we're going to plug it in where where x was alone. So plug it in for y when x was alone. Technically, you could plug it into any of the equations we've written that have both x and y, but it will be easiest if you do it in the one where x is already alone. Oop, equals. Okay, that was a negative y. That's why I made the 2 a negative 2. Negative 2 plus 3 is? 1. How would I write my answer?
1, 2.
1 comma 2 as an ordered pair. X comma y, no matter what order we had solved it in. Okay, these problems are time consuming. That's why you didn't have a ton of problems on your homework. Questions, concerns? Right now, based on class participation, I feel confident that like maybe 2 people know what's going on. Maybe 3. Okay. We'll try another one. The second way of doing substitution is to solve one of the equations for y. Get y alone. Again, this is like what we did yesterday, so this second option is just flip-flopped from the first. If we're solving one of the equations for y, then we've got to substitute into the other equation to solve for x, substitute x back in, and then get y finally. Okay? Which one of these equations is it going to be easiest to get y alone?
Negative 3x plus 3y equals 3.
You could do it pretty easily with that one, but I think it's even easier if we use the other one. Okay? It doesn't really matter to me. If this were your homework or your quiz or your test, you get to choose which of these y's you're getting alone. I think it's easier for the bottom one because it already has a coefficient of 1, which means I don't have to divide by anything. The only thing I have to move is the negative 5x. So I would say we need to solve this one for y. It is not wrong to do the other one, but in my opinion, it's easier to do this one because it just takes 1 step instead of 2. Somebody other than Jasha and Jermila, tell me how I'm going to get y alone here. Add 5x on both sides. Again, you can put 5x plus 13 or 13 plus 5x. Since we're not graphing it, it doesn't really matter which order it's in.
The y is alone, so you're done. Well, you're done with it. Right?
Very good. The y is alone, so we're done with that part of it.
And you plug it into the first problem, right?
Yep. So I'm going to rewrite them just so that we can see them separated. So I know I need this one, and the other equation I need is that top one that I haven't touched yet.
Negative 3 parentheses 5x plus 13.
We're going to be a little bit careful there. So these are the 2 equations we're using. We good with that? Those 2 equations? Now it's like yesterday. So I'm going to take this expression and plug it in for...
I just said that.
For what? For the y.
Oh, why?
Y is alone. We plug into y. So that's the tricky part about the fact that there's 2 different options for these is that you have to keep track of which one you're doing. If y is alone, you plug into y. If x is alone, you plug into x. So on this one, the negative 3x just stays out front. We will put parentheses where the y was so that we can plug this expression down into it. And it still equals 3 on the other side. Now we distribute.
15x.
Negative 3x plus 15x
Plus 39.
plus 39 equals 3. Combine like terms. What do you get?
12x.
Next up,
Subtract 39.
do it on both sides. 12x equals
42. Wait.
one's positive and one's negative.
36. Negative 36.
Negative 36. Subtract their values. Keep the sign of the larger number. Last thing to get x is
Divide by 12.
divide by 12. We get x equals
4, 3.
close. Close.
3.
Close.
Negative.
Negative 3. A negative divided by a positive is a negative. Are we done?
No.
No. After all that work, we still need to find
The other.
the y. So we've got this x. We're going to plug it in up here and find the y. So y equals 5 times negative 3 plus 13.
Negative 15 plus 13.
Negative 15 plus 13 is close.
1, 3.
Negative 2. The 15 was bigger and it was negative, so our answer is negative. All right. We've done all the work. Now we just need to write an answer. What is it?
3, 2. 3, comma 2. Negative 2.
Negative 3 comma negative 2. They're both negatives. Can't drop our signs. Questions, concerns about example 2? Okay. Need more time with this up there? All right, we are going to start this one off together, and then I'm going to have you work on the rest of it on your own before we go over the answer.
Use the first one.
Why do you think the first one, Jasha?
Because it's easy to solve for y. Right?
I think it's easy to solve for
X.
x. Always look to see if you have a variable with a coefficient of 1. That's always going to be the easy one to get alone. So we're going to take this top equation and we are going to solve for x. So I'll rewrite it down here so I've got some space to show what I'm doing. How am I going to solve that for x? Subtract 3y on both sides. X equals negative 3y plus 1. So when you start the rest of this problem, you're going to use that equation. So x equals negative 3y plus 1. Which other equation are you going to use?
Negative 3x. Subtract.
The second one. Negative 3x minus 3y equals negative 15.
Plug it in for x.
Okay, so here's where I want you to start trying the rest of it on your own because this is what we did yesterday. All right, let's finish walking through this. Anybody want to volunteer what they got as an answer, Jasha?
Like my last answer.
Yep, your final answer.
5, common.
5 comma negative 2. Anybody get a different answer? Dominic, what'd you get?
7 comma minus 2.
Okay, 7 negative 2. Any other possibilities? I haven't finished this yet, so I don't know who's right, if anybody's right. We're going to plug that in for x.
Wait, it's negative 5, common negative 2. That's right.
All right, we'll see. We plugged in for x. Remember, when you do that, you should only have y's left. If you have x's and y's at this stage, it's not possible to keep solving it. Okay, so we've only got y's. We need to distribute. You got to be careful with your signs when you distribute a negative. A negative times a negative is a positive 9y. A negative times a positive is a negative 3. What do you get when you combine like terms? Dominic?
6y.
Good. We've still got a negative 3 there. Add the 3. 6y equals
Negative 12.
negative 12. Last thing to get y alone. Y equals close. Negative 2. So both answers I heard involved y being a negative 2, so that's good. That's right. We agree there. We're going to take that negative 2 and bring it back up here to plug it in for y.
Wait, he's right, because I put it as
Oh. Okay. So we've got x equals negative 3 times negative 2 plus 1. Negative 3 times negative 2.
positive 6.
Positive 6 plus 1 is 7. So I agree with 7, negative 2 for our answer. Okay, if you didn't get that answer, or if you didn't finish the problem all the way on your own, do you see where you got stuck? How to get past it? Do you see what went wrong? How to fix it? Or do we have questions? Nothing? Okay, we'll go ahead and start the next one then. Ooh, too fast. There it is. All right, on this one, I'm going to actually write out a little note at the top. Give me plenty of room to write. Let's do a thumbs up, thumbs down. So let's say thumbs up, we should be trying to get a variable alone in the top equation. Thumbs down, we should try to get a variable alone in the bottom equation. Thumbs up for using the top, thumbs down for using the bottom, thumbs sideways, you got no idea how to choose. I'm only seeing like 4 thumbs. Seeing some sort of thumbs. Other side of the room's not showing me any thumbs. Well, a couple thumbs. Deontay, what do you think? I don't see your thumb.
Well, I mean, the bottom equation, the y is already by itself, so we would have to do the top.
The y's not by itself. So thumbs up, you want to get something alone in the top. Thumbs down, you want to get something alone in the bottom. Thumbs sideways, you got no idea what you're doing. So I saw several thumbs down, which I would agree with. We want to get something alone in the bottom equation. Let's see a thumbs up for getting x alone, thumbs down for getting y alone. We got some people that are flip-flopping their thumbs. I'm going to agree with those of you that said we should get y alone in the bottom. That doesn't mean that it's not possible to do it another way. But my note that I'm going to put up here is a suggestion. Get a variable alone that already has a coefficient of 1. That will always be the easiest. So coefficient meaning the number getting multiplied to it. So if it's got a coefficient of positive 1, that's going to be the easiest one to get alone. Questions about what I mean by that? Okay, so the bottom one has y with a coefficient of 1. How are we going to get it alone? Add the 5x to both sides. So, very good. Y equals 5x plus 19. So that is going to be one of the equations that I use. The other equation I have to use is the one we haven't talked about at all yet, which would be the top one. Negative 3x minus 8y equals 20. So here is where I want you to start doing it all on your own to practice. You're going to take that expression and plug it in for what? Y. You got y alone, you plug into y. Go ahead and give it a try on your own. All right, here we go. We're plugging in to y. We better be using parentheses when we do that. Questions about substituting in? Then we keep it moving. You better treat that 8 like it's a negative when you distribute it. Negative 3x. We've got negative 8 times 5x. What does that give me? Negative times a positive is a negative 40x. Again, we take a negative times a positive. That's going to give me a negative. That should come out to negative 152. Okay. So if you're taking 19 times 8, you'd get 72 and 80, 152. Okay. To keep solving it, we should combine like terms. Negative 3x minus 40x. What does that give me? Liam? Negative 43x. Okay, next up we have to solve. So we need x alone. What should we do? Add the 152. Do it on both sides. We would have negative 43x equals 172. Last step. Divide. X equals positive divided by a negative is a negative. That would come out to a negative 4. Yes, a calculator might make some of these calculations go a little quicker. Are we done? No, we're not. We found x. We still need to find y. So we're going to take that number for x, pull it all the way back up to the top here, and plug it in. When we do that, we would have y equals 5 times negative 4 plus 19. 5 times negative 4, negative 20 plus 19, negative 1. Our answer as an ordered pair -4 comma -1. Questions about example 4? Okay, we've done enough of these yesterday and today. They should be getting kind of repetitive. On this one, is there a variable that stands out right away that we should get alone?
No.
Not really. They don't have any coefficients of 1, which makes it tricky. So I would go through and say, is it going to be easy to divide by the coefficient? And when we divide, remember we have to divide everything by it. So for example, would it be easy to divide everything down here by a -7? No, you're going to end up with fractions that you don't get rid of. Okay, but if we look at the top one, which one would it be easy to divide everything by? -2. Which means we're going to be solving the top equation for x. So you have to be able to look at these and decide which equation and which variable you should be solving for. All right, you could technically go ahead and divide, but usually we move the y term first. How would we move the y term? Subtracting it on both sides. -2x equals -6y plus 6. Then we would do our division. Make sure you're doing it to every term and make sure you're dividing by a negative so your signs are coming out correct. So x equals, negative divided by a negative is a positive 3y. A positive divided by a negative is a -3. Keep track of your signs.
Divide by 3. Wait, no, never mind. I'm thinking just
Okay, x is already alone, so we're good to move on. It's almost like starting fresh. We're going to use x equals 3y minus 3. We're also going to use what?
-3. Wait, the bottom.
The bottom equation, the -7x plus 8y equals -5. Okay, we got x alone here. So we're going to plug that expression in for x in the other equation. The numbers in this one don't turn out as big, so go ahead and try the rest of this problem on your own. If you're still working, that's okay. We're going to start talking through it. I substituted in my expression for x, so now I need to distribute. Remember to keep track of your signs. A negative times a negative is going to make that a positive 21 back there. We would combine our like terms that are on the same side. So -21y plus 8y. -3y. We need to get y alone. So what should we do next? Subtract the 21. So we have -3y equals -26. Then we would have to, okay. Anybody notice anything about this? What's up, Dominic?
Wait, there was supposed to be a 1 next to a 3.
Yeah, it was supposed to be 13. You gave me 13.
Where at? Where did I miss that?
I just put -21 plus 8y, so I'm -30.
There we go. That I was like, that's not coming out what I wanted it to? Thank you.
As long as I can solve it.
All right. Good catch. So what do we get for y? -2. Is it negative? Positive 2, I think sounds better. Negative over a negative comes out positive. Questions, concerns about getting y? All right, we still need to get. We found y, we need x. We're taking it all the way back up to plug it in for y. So x equals 3 times 2 minus 3. 3 times 2 is
6,
minus 3 is
3,
beautiful. As an ordered pair, this would be,
so common
careful.
3 common
Okay, always x comma y, no matter what we found first. All right, we will finish some of these on Monday. So I am going to skip ahead because I definitely want to talk about number 7. Why aren't those loading? All right, there they are. Okay, why do you think I want to talk about 7?
has the same
Are there any variables that have a coefficient of 1? No. Are there any variables that have a coefficient that it's going to be easy to divide everything by? No. Sometimes that happens. So we'll go through this problem because it's not necessarily going to be pretty. When there's no great option, I like to divide by 2 because halves at least aren't as bad as things like thirds or eighths or fifths. So I'm going to choose to solve for x. Okay, this one, there's just not a really great option, but in my opinion, having halves is easier than having things like thirds. Everything is still getting divided by that 2. If you would rather write these with 0.5s, technically you can. I'm going to leave them as fractions. It's just not going to be very pretty. All right, so we're going to use x equals 7 over 2y minus 17 over 2. We also need to use that top equation, negative 5x minus 8y equals 17. This one's just going to come out to be kind of ugly. We're taking this expression, and where should we plug it in? For x. Good. X was alone. We plug into x. Equals 17. All right, pretty soon here, I'll go ahead and get rid of the fraction. For now, it's still going to be there. This negative 5 should just get multiplied to the number in the top. So it should be negative 35 over 2y. A negative times a negative makes that plus 85 over 2 minus 8y equals 17. Here's where we get rid of the fraction. We're going to go ahead and multiply the whole thing, everything on both sides, by a 2 to get rid of that denominator. We only do that once there aren't any other parentheses there. So when we do that, these 2's cancel. I get negative 35y. These 2's cancel. So that's plus 85. There's no 2 to cancel down here, so this becomes negative 16y. Again, no 2's to cancel with the 17. So it becomes a 34. From there, it shouldn't be too bad. You combine like terms. Negative 51y plus 85 equals 34. When you subtract the 85, you should get negative 51y equals negative 51. So y is going to equal a 1. So it looks a little ugly there in the middle, but our answer is actually coming out kind of nice. When we plug that 1 back in up here for y, x equals 7 over 2 times 1 minus 17 over 2. Multiplying by 1 doesn't change it. When you have a common denominator, you just have to subtract your numerators. 7 minus 17 is negative 10. Negative 10 divided by 2 is negative 5. So even though some of the work was a little ugly, the answer came out looking okay. We will do the rest of the examples from these notes on Monday.